7.1, part 1, it's on square roots. A lot of it you'll kind of already know, a little bit of it will be new. So first thing we need to write down is we need to talk about how many square roots something has. So if we talk about the square root of 9, remember that's asking what times itself equals 9. So what times itself is 9? 3 or negative 3 times negative 3 is also 9, right? Negative 3 times negative 3 is 9. So the square root of 9 is 3 or negative 3. Because if we do 3 squared, it's 9. And if we do negative 3 squared, it also equals 9. So something with the square root has two roots. Now, something we're going to talk about in a little bit, which I realize is a little bit confusing, is that if we use a square root symbol, we just want the positive square root. You don't have to write the negative one. We just want the positive one. We'll talk about that a little later. What if I asked for the square root of negative 4? What times itself is negative 4? Clay? Cameron? 2 times 2 is negative 4? Is that the same number times itself? McGill? Yeah, it's an imaginary number. There's no real solution. So this has no real solution. And you have to write that. You can't write like NA, because there is an answer. It's just an imaginary number. Because nothing times itself is going to ever equal a negative. No, that's not the answer. You could say, if you guys don't do this yet, but if you're just interested, the square root of negative 4 is 2i, because the square root of 4 is 2, and the I means the negative. So, you don't need to know this right now, though. Don't worry about it. All right. So we're gonna do an easy example. This is a ridiculously easy example, but find the two square roots of 36. How about just write them down on your paper right now? Don't say it out loud. Write down the two square roots of 36. And if it's a test or something, I'll be really clear if I want you to tell me the two square roots or just the positive one. So you should know. All right, raise your hand. What are the two square roots of 36? Lauren? Negative 6 and 6. That's it. See, some of these problems are really easy. All right, so we're going to talk about a sort of vocab word here. The principal, with the A-L at the end, not L-E. The principal square root. So if we're talking about the principal square root, that only refers to the positive one. It's the non-negative square root. And if we use the square root symbol, the radical sign, that indicates the principal square root. So from now on, if you see that square root symbol, that radical sign, that means I only want the positive one. I only want the positive square root. You don't have to give me both of them. And I don't want you to give me both of them. It would be wrong. Just give me the positive one. So I'm going to give you 4 examples, and you're going to simplify all of these. You should be able to do all of these with no calculator. All right, so the first one is square root of 25. Second one is the square root of the fraction 25/64. Third one is the negative, that doesn't look like a negative. The negative square root of 64. And the last one is the square root of 0.0049. You should be able to do all those without a calculator. So try those real quick. You can do that. Also, if you guys write your square root symbol on your paper like this, you can, but you don't need to write this little line on it. And some of your papers, I remember this from last year, they look super messy because you guys make this part so big. You guys like go like this. It looks awful. So just don't even do that part. Just go like this. I don't know. Don't write it. Just do this. Don't put the little line on it. Yeah, there's a 3 on the cube root. Try those 4. Yep. Well, they are watching it right now. Well, I mean, if they're hearing it. Clay, are you trying these 4 on your paper? All right, ready to go over them? All right, raise your hand. What's the square root of 25? Liv? 5. Yay, that's right. If you don't want me to say your first name on this video that like 4 people are going to watch that you probably know, don't raise your hand. Shh. All right, B, what is the square root of 25/64? What? 5/8 is correct. And if you're not sure, you just ask yourself what times itself is 25? It's 5. What times itself is 64? It's 8. Shh, just a second. C, raise your hand. What is the negative square root of 64? -8 is correct. Nice. So in this one, we just take the square root of 64, which is 8, and then the negative on the outside means, it kind of means like -1 times whatever your answer is. And then on D, what's the square root of 0.0049? Tyler? No, you put too many zeros. Liv? Here, answer this one first, and I'll answer questions. No. Esther? No. Clay? 0.07. So if you got that one on, we can answer questions on any of these, but if you got that one on like a test or something and you had no calculator, you could also think of it as a fraction. This is the square root of 49. This is the 10th place, 100th, 1,000, 10,000. So then we ask ourselves, what times itself is 49? 7. And what times itself will give us a 1 with 4 zeros after it? A 1 with 2 zeros, right? Right? 100 times 100 would put 4 zeros total. And this is 7 100ths, so you put a 7 in the 100th spot. You guys need to settle down. I'm going to send you out, okay? Liv. Yeah, you have to write it out. Sorry. Cameron? Because remember, the square root symbol means the principal square root, which is only the positive. Any other questions on those ones? You should be able to do all those without a calculator on a test or something. Jeb? If I said, like on that last one where I said, what are the 2 square roots of 36? Alright, I'm gonna go on. You can copy it from someone. I'm sorry, Jack, you were like talking the whole time there. So let's talk about what we say for this, even though I know you guys already know this. If you see something like that, that means that if you're gonna say it out loud to someone, you can say the square root of a you can just say root a, or you can say radical a. So I just want you guys to know that you could say any of those things and they would all mean the same thing. It would mean the square root of a. You can say root a, or you can say radical a. People don't usually say radical a. Alright, so the next vocab word is radical expressions. So a radical expression is just anything that has that radical symbol or the square root symbol in it. And then you can put whatever stuff you want in it. So like the square root of 5, that counts as a radical expression. You can have a variable in there, like the square root of a, that counts as a radical expression. You could have like negative signs, like negative square root of 3x. That counts as a radical expression, yeah? That's just what it's called. I don't know. I didn't make it up. You can have something like a fraction in a square root, like the square root of y squared plus 7 over y. You can have crazy things in there. You can have fractions in your square root. Or you can have something that has a square root and then other stuff like added or subtracted to it. Like the square root of x plus 8. Even though the 8's not in it, this whole thing counts as a radical expression because there's a square root symbol in it somewhere. Tyler? Mm-hmm. Yep, still counts as a radical expression. No? Okay, Clay, we're not talking about that. Alright. So, next vocab word, there's a lot of vocab today, is radicand. Radicand. And that is whatever you see in the square root symbol. So it's the expression under the square root sign. So whatever you see in that square root symbol, we call it the radicand. This is going to be a long video for these people. Alright, so what I want to do is talk really quickly, just so you guys can kind of recognize this graph. If we did the graph of y equals the square root of x, we're just going to do a little sketch of this graph. You don't need graph paper. You're not going to need it on your homework today either. Let's just figure out for a few values of x and y. First of all, what's the domain of this, or what can x not be? X cannot be negative, right? I can't take a square root of a negative number and have it be real. It would be not real. So let's just start with 0. If x was 0, what's the square root of 0? 0. What if x was 1? What's the square root of 1? Why would I not really want to put 2 on my table? The square root's a decimal. It's like 1.41. It goes on forever. So the next number I'd probably want to do is like 4. What's the square root of 4? 2. And we're just going to do those for now. I just want to show you like a little quick example of what the graph looks like. So our graph is only going to be this first quadrant up here, all the positives. So we've got a point at 0, 0. Thank you. And then if we go to where x is 1, y is 1. So 1, 1. That's a point. And then to get up to another y, we have to go over pretty far. We have to like go over a lot to get to the next perfect square. So I've got to go to 2, 3, 4 to get the next whole number for y. So 4, 2, and then your graph it's going to like be a curve like this. It should be a little nicer and prettier. But it's going to keep going up forever. It just doesn't go up very fast. So that's what the graph looks like. And then, just because we should practice this, let's write the domain and range. And we're going to write them in interval notation. You remember that? With the brackets and the parentheses? So for domain, remember that's what x can be. So what does x start at, and what's the biggest it gets to? Where does it start? 0. Does it hit 0? Yeah. Yep, so we do a bracket. 0 up to how much? Infinity. And what do you always put with a infinity? A bracket or parentheses? Parentheses, good. And then what about the range? That's what y can be. Domain is x, range is y. What does y start with? 0. What does it go up to? Infinity. So it's the same. The domain and range are the same for that. Just start like keeping that in mind because we're gonna have to start doing domain and range again. All right, we're gonna do 2 examples. We're like a little more than halfway done with those. We've got time. I know. So for these 2 examples, the instructions are find the indicated value. And we're going to use function notation here. This is pretty easy. We're just going to plug in numbers. So the first one is going to be f of x equals the square root of 3x minus 2. So 3x minus 2 is your radicand. It's what's in the square root. And what I want you to find is f of 1. And then our second one is g of z, just to use other letters for fun, is the negative square root of 6z plus 4. And we're going to find g of 3. You can if you want. I was going to do it together, but if you're done writing it, you can start. All right, so let's do these on the first one. Remember, this just means we're plugging in a 1 wherever we see an x. So f of 1 is equal to the square root of, instead of 3 times x minus 2, we're going to do 3 times 1 minus 2. Now, I know that you guys know 3 times 1, so you don't necessarily have to always write the 3 times 1, but I just think it's a good idea on your notes so you can like see what you did there. So 3 times 1 is 3, minus 2 is 1. So it's just the square root of 1, which is 1. That's it. That's your answer. See, these are not too bad. Just 1. On our second one, so we're going to plug in 3 for z. So we're going to do g of 3 equals the negative square root of 6 times 3 plus 4. So let's see, what's 6 times 3? 18 plus 4? So we've got the negative square root of 22. So for this one, I would say on your test or something what to do. Let's go ahead and, if you type this in a calculator, if you did square root of 22 in a calculator, it is 4.69. So is that my answer? What do I need to put? A negative, because there's a negative out there. That's it. So that one, you would be able to use a calculator to figure out what that square root was. I just rounded it. All right, let's do some more. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 10, 11 more examples. Ooh, okay. No, we shouldn't stop. We should just record all of class even if we get done. So we're going to evaluate the square root of a squared for each value. These are easy. All right, so whatever value they give us, we're going to square it, and then we're going to take the square root of it and see what happens. This is kind of just to see what happens for these. So the first one we're going to do is 5. So we're going to find the square root of 5 squared. So we're going to do, I'm just going to draw an arrow to show what I'm doing. We're doing the square root of a squared. So a is 5. So we're doing the square root of 5 squared. So 5 squared is 25. And what's the square root of 25? 5. We're going to see if that always is true. So on this one it was true, right? It equaled the first thing. So it looks like square and a square root kind of undo each other, right? So let's see. The second one we're going to do is 0. So we're going to do the square root of 0 squared. I know this seems dumb right now. So what's 0 squared? So we're doing the square root of 0. And what's the square root of 0? 0. So we ended up with the same number again. Oh my goodness. All right, let's do one more. What if we do negative 5 this time? So we did a positive, a 0, and now we're doing a negative. So on this one, we're going to do the square root of, now remember, whenever we're plugging in a number, you always do it in parentheses. So we're doing the square root of negative 5 squared, and we're squaring the whole negative 5. So what's negative 5, all of it squared? 25. And what's the square root of 25? 5. So that's the only thing where it was different. If you're putting a negative in there and you square it and then take the square root, it just turns to a positive. So what this shows us, that was a bad symbol. Just do a little squiggly thing. If you do the square root of any number squared, the answer is always whatever you had right here, but you make it positive. What kind of math symbol shows that we make something positive? No. It's 2 words and it starts with an A. Come on. It's 2 words. The first one starts with an A and the second one starts with V. V is in victory. You guys don't know it? Wait. Something value. Angle value. And true value. Absolute value. The absolute value makes something positive, right? Because it means the distance from 0. We did a big, huge unit on this in the beginning of the year. Okay, we have to write something kind of long here, okay? So, when a radicand, so when the thing inside the square root So when a radicand, the thing in the square root, is a perfect square, so when it is a square, we need absolute value signs unless we know that the expression being squared is non-negative. I know that's long. I'll give you a second to write it. 0, yeah. No. So the only way, what it says, unless we know that the expression being squared is non-negative, the only way you would know that, are you guys okay? The only way you would know, I'm going to change what I sign on people's papers if this continues to be a problem. So the only way you're going to know something is non-negative is the book or something is literally going to tell you it is not negative. Like, it's going to tell you that. Yeah? No, you won't know. If it does not say assume this is non-negative, then it could be negative. Because you're gonna have a variable in it. Yeah. Yeah. So let's do some examples where we see this. So this example, the instructions are just simplify, but then it gives us some really important note. It says assume that the variable can represent any number. So it could be negative. So when it says assume the variable can be anything, that means it could be negative, and that means we have to be careful, because if we take the square root, we only want the positive ones to come out of the square root. So it's really easy to do this. We're just going to do these problems like we would normally, but we're just going to put an absolute value sign around them. So the first one is we're going to do the square root of 36t squared. So is the radicand, is what's in there, is that a perfect square? Yes. What times itself is 36t squared? Yeah, this is the same as 6t squared, right? So this is a special case where we have to use the absolute value symbols because it's a perfect square in there. It's special. So this means that our answer is, well, the square root and the square kind of undo each other. So our answer is just 6t, but what symbol do we have to put around it? We have to put absolute value around it. Because we want to make sure that we only are getting the positive answers. Or if you wanted, you can just put the absolute value sign around that t, since they're just being multiplied. Honestly, I wouldn't do that if I were you. I would just always leave it like that. But if you wrote it like that, I would count it right. Because the 6 is never going to be negative. The t could be negative. Honestly, I would just do this because then you have less chance of getting it wrong. If you just stop there. No, this would be right, too. Either of these would be right. Let me, well, because then you might have taken an extra step to do that. And it's like, the more steps you do, the more chance you're going to get it wrong. Right. So let's do another one. Let me show you. This one, you're not going to be able to do that. So let me show you. Let's do the square root of x plus 1 all squared. So it's kind of a dumb question. Is that a perfect square in there? Yeah. So the square root and the square kind of undo each other. It's just x plus 1, but you have to put the absolute value sign around it. And in that one, you couldn't write it another way like that because they're being added. So that's why I'm saying, I'm just telling you this because of the book. I'm just telling you this because the book says it. Just do an absolute value sign around it, and then you'll be good. Yeah? You have to put it around the whole thing. I just said that. No. It doesn't work. Because adding one, when you're adding or subtracting, it really depends on if what this number is, if it ends up positive or negative. Multiplying and dividing, it doesn't matter. It's like how my younger kids, they always want a rule. Like, what if I add a negative to a positive? Is the answer going to be positive or negative? I'm like, I don't know. It depends on what the numbers are, you know? Oh, sorry. Yeah, exactly. So when you're adding or subtracting, you can't do it. It messes it up. All right, C, this guy. Square root of x squared minus 8x plus 16. Sorry, I know I'm in some of your way. Is this a perfect square?
Yes. No. No, it's not.
Is it a perfect square trinomial?
No.
Let's see.
Yes, it is. Never mind. Sorry.
This is a perfect square. This is a perfect square. Is the middle negative 2 times this times this? Yeah. So this is a perfect square trinomial. This is the same as x plus or minus 4. Minus because of that minus sign. So this is the same as x minus 4 all squared. So you've got to be able to catch that. So then the square root and the square cancel each other out. And we just put an absolute value sign around what's in there. So we're just trying to see if what's in the square root can be written as a perfect square. That's all we're doing. Yeah? Nope. Because a plus or minus messes it up. In algebra, plus and minus messes a lot of things up. It does. Just like how yesterday, remember I got mad yesterday because one of you guys tried to say this was x squared plus 4? No. The plus and minus messes it up. No. Nope. Nope. All right, so this one, can we write t to the 6 as something squared? Raise your hand. What can we write as the, like, something squared? Sweta? Yeah, you should need to raise your hand when I ask you to raise your hand, okay? So this is t cubed squared. So I just rewrote it, but I wrote the t... Oh, sorry, I don't know why I wrote absolute value sign around that. I'm just getting used to it. I meant to write a square root. We're taking the square root of it, and we're going to put an absolute value in the end. Because if the inside is a perfect square like this, we cross out the square in the square root, and we just put an absolute value sign around what's in there. And that's our answer. I'm just doing a ton of these so you'll remember. Alright, let's do another one. If you guys don't get it, we'll just keep doing more. So, can we write this as a perfect square?
Yes.
Raise your hand.
No.
How can we write this as a perfect square? What would be squared? Elise? Yeah, we can write this as a to the 4 squared. That would be a to the 8, right? The square root. So I just rewrote it. Just looks a little different. So since I can write what's in the square root as a perfect square, I have to put absolute value around my answer. I take those out, and I just write a to the 4 with an absolute value. So if what's in your square root is a perfect square, you just take away the square and square root, and you put an absolute value around it. Okay, good. Alright, we're just going to do 3 more examples. Well, they're going to have a fun time watching this video. We're going to do this fast. I don't have time for questions, I'm sorry. I know I'm being a bad teacher, I'm sorry. Alright, so on this one it says simplify, and then it gives us a note. Hey, these things, you can assume they're non-negative. What this is saying, it's a little message to you that says you don't need the absolute value symbol. So we're going to do these just the same as we did the other ones, but you don't have to put the absolute value because it already says, hey, they're non-negative. So the first one is the square root of y squared. Raise your hand if you can tell me what the square root of y squared is. Elise? Y, that's it. Square root and square cancel each other. You don't need absolute value because it already told you it was non-negative. Alright, 2 more. B is the square root of a to the 10. Can we write a to the 10 as a perfect square?
Yes.
Liv? Tyler, was your hand up? A to the 5 squared, right? So if we're taking the square root of something squared, the square root and the square cancel each other out, and it's just a to the 5th. You don't have to rewrite it like that if you get to the point where you don't need to do that anymore. You can skip from the first step to the last step. And then the last one is, oh goodness, why did I do this? The square root of 9x squared minus 6x plus 1. Sorry, I'm going to go fast. Do you think this is the perfect square trinomial? I bet it is because I happen to put it in this section. The square root of this is 3x. The square root of 1 is 1. Is this negative 2 times 3x times 1? Yes. So this is the same as the square root of 3x minus 1 squared. The square root of the square cancel out, and it's just 3x minus 1. Okay. So the bell's going to ring in like 10 seconds. You have homework tonight. You have to do page 440, number 9 through 48, multiples of 3.